Hello everyone, good morning. This is lecture number 8 of ordinary differential equation. So if you haven't watched the previous 7 lectures, go through that. This is the continuation of previous class. If you have watched all the previous videos, you are ready to go, right? Okay. So far, for the past 7 lectures, what we are doing this, we have been solving the differential equations of first order and first degree. And in the very first lecture, I have given you that there are many methods to solve a differential equations of first order and first degree, right? This is the notes of the very first class where I have given you that there are 8 methods to solve a differential equations of first order and first degree. So we have completed the first 4 methods: variable separable method, equation reducible to the form in which the variables are separated, and homogeneous equations and the equation reducible to homogeneous, right? So in this class, we're going to start the fifth method, which is linear differential equations, right? So linear differential equations. So we will go through what is meant by linear differential equation and what will be the general form of a linear differential equation and how to solve. After that, we will do problems based on linear differential equations, right? So is there any doubt? Okay, so we'll start today's class, right? Okay, so we will start linear differential equations. This is very important UPSC point of view. So 50% there is a chance that there will be a problem based on linear differential equations, right? So linear differential equation. So first I will tell you the general form. After that we will define, right? The standard form, the standard, the standard form of standard form of the standard form of a linear differential equation of first order. Of first order is given by very important, right? So is given by dy by dx, right? Dy by dx plus py is equal to q, right? Dy by dx plus py is equal to q. Very important. Where this p and q, right? Where this p and q are functions of x only, right? Very important. This p is a function of x and q is a function of x, right? That is p is a function of x and q is also a function of x, right? Both are functions of x only. So whenever you have an equation of the form dy by dx plus py is equal to q, where p and q are functions of x, this is called linear differential equation, right? This is called linear differential equation, right? So we will define what is meant by this is a general form. This is general form. Now we will define precisely what is linear differential equation. You know what is meant by homogeneous differential equation, right? That we discussed in the previous classes. A linear differential equation, right? So we will define definition. A linear a linear differential equation is that is that in which is that in which the dependent variable in which the dependent variable in which the dependent variable in which dependent variable and its differential coefficient, its differential coefficient occur occur only in the first degree uh, and are not multiplied together. Right? So this is a definition. Actually, this is a general form of linear differential equation. Definition, what it says is a linear differential equation is that in which a dependent variable and its differential coefficient, right? Is if you have y is a function of x, right? If you have y is a function of x, then this y is called dependent variable, right? Y is called dependent variable. It is depending on x, right? So this y should be, right? So in dy by dx plus py is equal to q. A linear differential equation is that the dependent variable and its differential coefficient occur only in the first degree, right? That is, this dy by dx degree has to be 1, and and dependent variable also should be of the first degree, that is y also should be of power 1, and this dy by dx is also of power 1, right? Then we say this is a linear differential equation, but you just understand the general form of the linear differential equation. So what is the general form? It is dy by dx plus py is equal to q, right? P and q are functions of x. Now, how to solve this equation, right? How to solve this equation is what we are going to do next, right? Okay. How to solve this equation? Okay. So to solve dy by dx plus py is equal to q, right? Where p and q are functions of x, right? Where p and q are functions of x. Okay. So how to solve this equation, right? So I'll tell you that first we will try to get the formula to solve this type of equation, right? Okay. So what I'm going to do is I'm going to multiply throughout by, so multiply throughout by e power integral p dx, right? So I'm going to multiply throughout by e power integration of p dx, right? I'm going to multiply throughout by this. So after doing this, what will happen? That is, I'm multiplying e power p dx throughout, right? So we have dy by dx, already we have dy by dx into e power integral p dx plus already we have py. I'm multiplying e power integral p dx is equal to q into e power integral p dx, right? I have just multiplied throughout by e power integral p dx. Call this as equation number 1, right? Now consider, right? I'm going to consider, now what will be d by dx of, right? What will be d by dx of y into e power integral p dx, right? I'm going to find out this value so that you will get to know something about it, right? I'm going to find what is d by dx of y into e power integration of p dx, right? So we will apply uv method here. So u into v dash plus v into u dash, right? So y into d by dx of u into v dash. So e power integration of p dx plus we will keep e power integral p dx constant, and this will be dy by dx, right? So u into v dash plus v into u dash. Now what about this value? So y into, so d by dx of, so we know d by dx of e power f of x, right? E power f of x is e power f of x into f dash of x, right? This is a derivative of e power f of x. So you treat this full as f of x, right? You see this full as f of x. F of x here is integration of p dx. Integration of p dx. So e power f of x. So e power f of x e power f of x into f dash of x, right? Here f of x is integration of p dx. Is it clear, right? E power f of x into f dash of x, that is derivative of this. So d by dx of this plus, so we'll keep this as it is, e power integration of p dx into dy by dx, right? So this will be equal to, so this integration and this derivative will get cancelled. So we have y into e power integration of p dx into capital P, and these two will get cancelled because these two are inverses, right? Into e power integration of p dx into dy by dx, right? So I can write this as capital P into y e power integration of p dx plus dy by dx into e power integration of p, right? Now you can see we have got these two, right? We have got these two, that is these two terms are nothing but d by dx of y into e power integration of p dx, right? So that means I can replace, let us call this as 2, right? So put 2 in 1. So you can see these two are these two terms, right? Py e power integral p dx plus dy by dx e power integration of p dx. So I can replace these two terms to be d by dx of y into e power integration of p dx, right? So one becomes, so this I can replace this entire term to be d by dx of y into e power integration of p dx is equal to, already we have q into e power integration of p dx, right? E power integration of p dx. So we have d by dx of something is equal to q. Integrate on both sides. Integrate on both sides. So if I integrate this, this will be what? Integration of d by dx of y into e power integration of p dx is equal to integration of, so integrating with respect to x, right? So integrating with respect to x, let's call this to be dx. Integration of q into e power integration of p dx dx. Right, I'm going to integrate. I'm just integrating with respect to x on both sides, right? So these two will get cancelled, right? Derivative and inverse. So this implies we have y into e power integration of p dx is equal to integration of q into e power integration of p dx into dx plus c, right? Which is the required solution. We have got y, right? So y can be obtained by just bringing this e power integral p dx to downside, right? Okay, which is the required solution. This is the required solution of the given linear differential equation, right? Don't think big, right? So whenever you see an equation of the form dy by dx plus py is equal to q, where p and q are functions of x only, then this equation is called linear differential equation. The solution is given by y into e power integration of p dx is equal to q into e power integration of p dx into dx plus c, right? The term, the factor, right? The factor e power integration of p dx is called integrating factor, right? So we're going to name this as integrating factor, right? So I can replace this as y into integrating factor is equal to integration of q into integrating factor dx plus c, right? This is a solution of the linear differential equation. So in order to find solution, you have to find integrating factor, where integrating factor is given by e power integration of p dx, right? E power integration of p dx. In order to find solution, you have to find integrating factor first, right? You have to find integrating factor that after that substitute in this equation. This is the solution, right? Very simple. So we'll start solving problem. The solution, we already know the solution is what? Y into integrating factor is equal to q into integrating factor dx plus c. Q is the one that we can obtain from the question, right? That is the RHS part. That is dy by dx plus py is equal to q. This p and q can be obtained from the question, and you have to make sure that the coefficient of dy by dx is 1, right? So make sure, note, right? Notice the coefficient of dy by dx, if not unity, right? If not unity, must be made unity. Must be made unity means 1, right? Must be made unity by dividing throughout by that, right? By dividing throughout by it. By dividing throughout by it. Suppose if I have something like x, so divide throughout by x, right? Suppose if I have something like x plus 1, you divide throughout by x plus 1, so that this will be, quotient will be 1, right? So we will just recall what is linear differential equation. So whenever you have dy by dx plus py is equal to q, where p and q are functions of x only. How to solve this equation? The solution is given by y into integrating factor is equal to integration of q into integrating factor dx plus c. This q can be obtained from the question, and the integrating factor formula is e power integration of p dx, right? And also make sure you know this note, right? Note 2 is e power log f of x is f of x, right? So e power log f of x is f of x. You know this. Okay, so can we start solving problems? Is it clear? Can I do problems? Is there any doubt? No doubt, right? So we'll start solving problem. Solve 1 plus x square dy by dx plus 2xy is equal to 4x square, right? So you can see it is of the form dy by dx plus py is equal to q, but you make sure that the coefficient of dy by dx must be 1. So what we'll do is we'll divide throughout by, so divide by 1 plus x square throughout, right? So therefore this will be dy by dx 2x divided by 1 plus x square into y, 4x square divided by 1 plus x square, right? So which is of the form dy by dx plus py is equal to q, right? So which is of the form, dy by dx plus py is equal to q, where what is p here? So p is given by 2x by 1 plus x square, q is given by 4x square by 1 plus x square. P and q are functions of x1, right? Okay. So we know that the solution is given by, and what is the solution? It is given by y into integrating factor is equal to integration of q into integrating factor dx plus c. This is the solution, right? Call this as equation number 1. Now first we will find if, and then we will substitute back here. Now what is integrating factor formula? So integrating factor formula is e power integration of p dx. So e power integration of, so what is p? So p is 2x by 1 plus x square dx. So f of x, f dash of x. This e power log of 1 plus x square, right? So we know that integration of f dash of x by f of x is log f of x. Okay. So this will be e power log f of x is f of x. So our integrating factor is 1 plus x square, right? Substitute back in 1. Y into integrating factor is equal to q into integrating factor dx plus c is the solution. So y into integrating factor is 1 plus x square. Integration of, so what is q? Q is 4x square by 1 plus x square into integrating factor dx plus c. These two will get cancelled. So we have y into 1 plus x square is equal to integration of 4x square dx plus c, right? So this will be 4 into integration of x square is x cube by 3. So therefore y into 1 plus x square, y into 1 plus x square is equal to 4x cube by 3 plus c is the required solution. This y is equal to 4x cube by 3 plus c divided by 1 plus x square, right? Very simple. So whenever you see dy by dx, right? So if we have an equation of the form dy by dx plus py is equal to q, where p and q are functions of x only, then it is called linear differential equation. It is called linear differential equation. And how to solve this? You have to use the solution is given by y into integrating factor is equal to integration of q into integrating factor dx plus c, right? Okay. We'll move on to second problem. So solve dy by dx plus y into secant x is equal to tan x, right? So it is of the form dy by dx plus py is equal to q. So we will directly write the solution. Solution is given by y into integrating factor is equal to integration of q into integrating factor dx plus c, right? So first we will find integrating factor. So e power integration of p dx. So e power integration of, so here p is what? Secant x, right? Py is equal to q. So integration of secant x dx. So what is integration of secant x, right? So integration of secant x is e power secant x is what? Log secant x plus tan x, right? So integration of secant x is log secant x plus tan x. So e power log f of x is f of x. So this will be, I have given you all the formulas of integration and differentiation. The very first class itself, go through that, right? You can get all these formulas. So integration of secant x is log secant x plus tan x. So integrating factor is secant x plus tan x. Let's call this as 1. So from 1 we have y into integrating factor is equal to integration of q into integrating factor dx plus c. So y into integrating factor is secant x plus tan x integration of q. So what is q? Q is tan x. Integrating factor is secant x plus tan x dx plus c, right? So you have to integrate this. So integration of, I can write this as secant x tan x dx, right? Secant x tan x dx. Integration of tan square x dx plus c, right? So this is integration of secant x tan x, right? Integration of secant x tan x is secant x, right? I given you all the formulas, right? This I can write this as, I can write integration of secant x tan x dx to be integration of d by dx of secant x, right? D by dx of secant x. Secant x derivative of secant x is secant x tan x. So I can write secant x tan x as d by dx of secant x. I've given you all the formulas, right? Go through all the formulas. Secant x. So this two will get cancelled, right? Integration differentiation. So we'll have secant x. and integration of tan square x dx. So integration of tan square x dx, you can write this as integration of um, secant square x minus 1, right? Cos secant square x, secant square x plus tan square x is 1. So therefore tan square x will be secant, secant square x minus tan square x is 1, right? Very basic entities. I'm just replacing here. Tan square x is secant square x minus 1, right? So you know this entity, right? Tan square x is secant square x minus tan square x is 1. So therefore tan square x can be written as secant square x minus 1, right? Very basic entity. And this will be secant x, and integration of secant square x is tan x, right? Because derivative of tan x is secant square x, will be tan x, and minus dx. Minus dx will be minus x plus c, right? Because I can write secant square as d by dx of tan x. Right? So it's a very basic formula. C required solution. Right? So we move on to next problem. You have to make sure that whenever the equation of the whenever the equation is of the form dy by dx plus py is equal to q, so you make sure that it is a linear differential equation, right? The solution is given by y into integrating factor is equal to q into integration of q into integrating factor dx plus c. Solve dy by dx plus y by x is equal to x squared, right? So which is a linear solution. So it is of the form dy by dx plus 1 by x into y is equal to x, which is a linear differential equation, right? LDE. So p is given by 1 by x, q is 1 by x squared. Solution is the solution is y into integrating factor is equal to integration of q into integrating factor dx plus c. Now what is integrating factor? E power integration of p dx. So e power integration of, so p is 1 by x dx. So e power log x, which is x, right? So integration of 1 by x is log x. So so you have e power log x, which is x. So your integrating factor is x. Let's call this as 1. So from 1 we have y into integrating factor is equal to integration of q into integrating factor dx plus c. So y into integrating factor, y into integrating factor is x, integration of q. So what is q? Q is x square, integrating factor is x into dx plus c, right? So we have yx is equal to integration of, so we have xy is equal, this will be x cube dx, which is x power 4 by 4 plus c, right? Which is the required solution. So y is equal to, you divide by x, you will get y as my solution, right? Okay. On to fourth problem. To solve, dy by dx is equal to y tan x minus 2 sin x, right? Y tan x minus 2 sin x. So it is of the form dy by dx, right? Let's write this as minus tan x into y is equal to minus 2 sin x, right? So dy by dx plus py is equal to q, which is a linear differential equation where p is given by minus tan x, q is given by minus 2 sin x, right? The solution is given by y into integrating factor integration of q into integrating factor dx plus c, right? So what is integrating factor? E power integration of p dx. So e power integration of, so p is minus tan x dx, right? So integration of minus tan is log cos x, right? This can be done as integration of minus, so sin x by cos x dx. So f of x, f dash of x, right? So you write this as minus sin x, right? F of x, f dash of x. Derivative of cos x is minus sin x. This is nothing but e power log cos x. So e power f of x is f of x. E power log f of x is f of x. So integrating factor is cos x, right? Therefore, 1 becomes y into integrating factor is equal to integration of q. So q is minus 2 sin x into integrating factor dx plus c, right? So sin 2 theta is 2 sin theta cos theta, right? Sin 2 theta is 2 sin theta cos theta. This I can write this as minus integration of 2 sin theta cos theta. This is sin 2x dx plus c. So y into cos x, integration of sin 2x is minus cos 2x by 2 plus c. Right? This is the required solution. That's it. Y cos x is equal to minus cos 2x by 2 plus c, right? Sorry, plus, right? Because integration of sin 2x is minus cos 2x. So minus minus will become plus. So we will have plus cos 2x, 2 plus c. The required solution. Right? So move on to the problem. So solve secant x dy by dx is equal to y plus sin, right? Solution. First, we will divide by secant x to make sure the coefficient of dy by dx should be 1, right? So we will have dy by dx minus is equal to y by secant x sin x by secant x, right? This is of the form dy by dx minus 1 by secant x into y is equal to sin x by secant x, right? So dy by dx plus py is equal to q, or you can write it dy by dx plus py is equal to q, which is a linear differential equation, right? The solution is given by y into integrating factor is equal to q into integrating factor dx plus c, right? Okay. So this can be written as sin x cos x, right? Because 1 by secant x is cos x. The solution is given by y into integrating factor integration of q into integrating factor dx plus c, right? Okay. Now what is integrating factor? E power integration of p dx, e power integration of, so p is minus 1 by secant x minus 1 by secant x is p, right? This can be written as e power minus cos x d, right? So 1 by secant x is cos x. So integration of cos x is sin x. So e power minus sin x is the integrating factor, right? Usually in all the problems we have log of something, so that we have this e and log will get cancelled. But here we have e power minus sin x. So we substitute in 1. So from 1 we know the solution is y into integrating factor is equal to q into integrating factor dx plus c. So y into integrating factor is e power minus sin x equal to integration of q into integrating factor, right? q into integrating factor. What is q? So q is sin x by secant x. Sin x by secant x. Integrating factor is e power minus sin x dx plus c. So you will keep this, you will all, this term will remain same as it is, right? The only thing is you need to perform this integration. This will be sin x cos x, 1 by secant x is cos x into e power minus sin x dx plus. So we need to integrate this, right? That is, we need to integrate integration of sin x cos x e power minus sin x. So put t is equal to sin x. So very easy problem, right? So put t is equal to sin x. So therefore dt by dx will be cos x. So dx will be dt by cos x, right? Dx is dt by cos x. Dx is equal to dt by cos x will be integration of t sin x and this dx cos x. Okay, what we can do is, okay, no problem. Let us keep this cos x as it is. Cos x e power minus t and dx is dt by cos x, right? Plus c will be integration of t into e power minus dt, t into e power minus t dt plus c. So apply integration by parts. So uv minus integration of b du, right? So you know that integration of u dv is uv minus integration of b du. You have to choose u in the order I late, right? I already explained. I stands for inverse trigonometric functions, inverse functions, logarithmic functions, algebraic functions, uh, trigonometric functions, and exponential functions. Right? Inverse function, logarithmic, algebraic, trigonometric, exponential. Here you have algebraic and exponential. Algebraic comes first, so put u is equal to t, dv to be equal to e power minus t dt. Right? Therefore, du will be equal to dt. B is integration of this, right? So dv is, this means integrate on both sides. So b is e power minus t by minus 1, right? This will be uv. So u into b is e power minus t minus integration of b is e power minus t, du is dt. So minus t into e power minus t. So minus minus will become plus integration of e power minus t dt plus c. So minus t into e power minus t minus e power minus t plus c, right? This is the required solution. This is the required solution. So replace t by sin x, right? So if you take, I can take e power minus t common, right? Or minus e power minus t common. This will be t plus 1, right? So y into e power minus sin x. So replace t is equal to sin x. This is the required solution, right? So whenever you see it is a linear differential equation, solution is given by this formula. You calculate integrating factor and substitute back here. So integrate this, you will get the solution, right? So move on to sixth problem. Solve. Is there any doubt? Dy by dx plus y into tan x equal to secant x, right? Y into tan x is equal to secant x. So we have dy by dx plus dy equal to q, right? Which is which is a linear differential equation, which is of the form dy by dx plus py is equal to q, where p and q are functions of x. Solution is given by y into integrating factor is equal to integration of q into integrating factor x plus c, right? So we will find integrating factor. So e power integration of p dx. So e power integration of tan x dx. So e power integration of sin x by cos x. So here minus is missing, right? So multiply by minus will be e power minus log cos x, right? Power minus log cos x, e power minus log of cos x, right? Because minus is missing, cos x here is minus sin x, right? So this is nothing but e power log of cos x the whole power minus 1. So e power log f of x is f of x. So cos x whole power minus. So 1 by cos x is your integrating factor, right? So don't put minus cos x and write it like that, right? So if you are having minus you are having minus sign before log, you take that to power, okay? You take that to power so that this minus will go to power and this will come right, right? Okay. This if whenever you have some coefficients or constant before log, you take that to power, right? Power property of log. Okay. So 1 by cos x, which is nothing but secant x, right? So secant x is your integrating factor. So 1 becomes y into integrating factor is equal to integration of q into integrating factor. So secant x into secant x dx plus c. So y into secant x. So integration of secant square x dx plus c. This is tan x, right? This I can write this as d by dx of tan x to dx plus c, right? Derivative of tan is secant square x. So these two will get cancelled. So we have y into secant x is equal to tan x plus c. It's the required solution. We move on to 7th problem. On 7th problem now. Solve 1 plus x square dy by dx plus 2xy is equal to cos x, right? So first what we will do is we will divide by 1 plus x square throughout. So we have dy by dx 2x by 1 plus x square y is equal to cos x by 1 plus x square, which is a linear differential equation, right? This is a linear differential equation. The solution is given by y into integrating factor is equal to integration of q into integrating factor dx plus c. So we will find integrating factor e power integration of p dx. So e power integration of what is p? P is 2x by 1 plus x square dx. So which is nothing but log of 1 plus x square, right? F of x, f dash of x is 1 plus x square, right? So again I'll repeat, go through all the previous videos, then only you will have more, you will solve problem more faster, right? So integrating factor is 1 plus x square. So 1 becomes y into integrating factor integration of q into integrating factor dx plus c. These two will get cancelled. So y into 1 plus x square integration of sin x plus sin x, sorry, integration of cos x is plus sin x plus c is required the required solution, right? On to the eighth problem. So solve x into log x dy by dx plus y is equal to 2 log x plus y is equal to 2 log x. So you can see you just divide by x into log x throughout, right? You divide by x into log x throughout, so that the coefficient of dy by dx is 1, right? Okay. So divide this, you will have dy by dx plus 1 divided by x into log x, 1 by x log x y, 2 log x divided by x into log x, right? These two will get cancelled, which is a linear differential equation, right? So P is 1 by x into log x, Q is 2 by x. Solution is given by y into integrating factor is equal to integration of Q into integrating factor dx plus c. So now we'll find integrating factor e power integration of p dx, e power integration of p is 1 by x log x dx. This can be written as integration of 1 by x by log x dx, right? By x by log x dx, f of x, f dash of x. So log of f of x. So f of x is log x here. So we know integration of f dash of x by f of x is log of f of x. So here f of x is log x. Log x, derivative of log x is 1 by x. So e power log f of x is f of x. So log x is your integrating factor. So 1 becomes y into integrating factor equal to integration of what is q? Q is 2 by x, right? Q by x into integrating factor dx plus c. Now we need to integrate integration of 2 by x log x dx plus c, right? Now you can see this, I can write this as, if I take 2 outside, we have 1 by x into log x dx plus c, right? So what is this? What is the integration of log x by x? Very simple, right? So what is integration of f of x whole power n? It is f of x whole power n plus 1 by n plus 1 into f dash of x, right? This is a formula for f of x whole, sorry, yes, 1 by f dash of x, right? What is integration of f of x whole power n? F of x whole power n plus 1, f of x whole power n plus 1 by n plus 1 into differentiate this 1 by f dash of x, right? Now, what about integration of yeah, 1 by x log x, right? Okay, okay. That means integration of f of x whole power n, you just multiply this f dash of x here into f dash of x dx is equal to f of x whole power n plus 1 by n plus 1. So you can see f of x integration of f of x whole power n into f dash of x. This is nothing but what? F of x whole power n plus 1 by n plus 1. Clear? So here n is 1. Just compare here. If you take f of x to be equal to log x, you will have this term, right? F of x whole power n, you take n to be equal to 1. You take f of x to be equal to log x, this n is not equal to minus 1, right? Okay. You take f of x to be equal to log x, and n to be equal to 1, you will get this left hand side, right? Nothing but 2 times f of x whole power n plus 1 log x whole power n plus 1 divided by n plus 1. Is it clear? So we will have 2 into log x whole square by 2 plus c. These two will get cancelled. So we have log x whole square plus c. What is left hand side? Left hand side is y into log x. So y into log x is equal to log x whole square plus c is a required solution. So whenever you have f of x, f dash of x, right? So f of x into f dash of x whole power n, you will make use of this formula, right? Okay. So we'll move on to ninth problem now. So solve cos square x dy by dx plus y is equal to tan x. So we will divide throughout by cos square x. So divide by cos square x, we have dy by dx plus 1 by cos square x into y is equal to tan x by cos square x, right? Which is a linear differential equation because it is of the form dy by dx plus py is equal to q. Solution is given by y into integrating factor is equal to integration of q into integrating factor dx plus c. Now we will find integrating factor e power integration of p dx. So e power integration of p to dx. So p is what? 1 by cos square x into dx. So integration of 1 by cos square. This will be integration of secant square x. This is nothing but d by dx of tan x. So this will be power tan x, right? So integrating factor is e power tan x. So 1 becomes y into integrating factor is equal to integration of q into integrating factor dx plus c. Y into integrating factor is e power tan x is equal to integration of q into, what is q? Q is tan x by cos square x, right? Tan x by cos square x. Integrating factor is e power tan x dx plus c. So 1 by cos square x, I can write it as secant square x. Tan x secant square x e power tan x dx plus c. So again put t is equal to tan x. So therefore dt will be derivative of tan x is secant square x. Secant square x dx, right? So this is somewhat similar to the same problem that we solved in second problem, I think. So this will be integration of, so t is tan x. So integration of secant square x dx. Just combine this term, right? So dx into secant square x is dt. It is dt. This dt, so t into e power t dt plus c. Integrate this. This will be uv minus integration of v du. U is t, dv is e power t. So du is equal to tt, v is equal to e power t. So u into v, so t into e power t minus integration of e power t dt. So t e power t minus e power t. So if we take e power t common, we will have t minus 1, right? Replace t to be equal to tan x, e power tan x to tan x minus is the required solution. So y is equal to we have y into e power tan x. So this tan x will get cancelled. So we have y is equal to tan x 1 plus, actually we cannot cancel this e power tan x, right? Because c is also here. If you are cancelling this e power tan x, you have to take e power tan x common. So that we will have e by e power tan x plus, let us keep this as it is, right? We have c here, right? You can take e power tan x outside, so that this will be tan x minus 1. This will be c divided by e power tan x. Then you can cancel, right? The required solution. We'll move on to 10th problem. Solve dy by dx 2x by x square plus 1 into y equal to 1 divided by x square plus 1 whole square, given that y is equal to 0 when x is equal to 1. This is given just to find out the value of the arbitrary constant, right? Okay. So solution. So we have dy by dx plus py. So 2x by x square plus 1y is equal to 1 divided by x square plus 1 whole square, which is a linear differential equation, right? dy by dx plus py is equal to q. The solution is given by y into integrating factor is equal to q into integrating factor dx plus c. So we will find out integrating factor e power integration of p dx. So e power integration of, so p is 2x by 1 plus x square dx, which is nothing but e power log 1 plus x square, which is nothing but 1 plus x square. So 1 becomes y into integrating factor integration of q. So q is 1 by x square plus 1 whole square into integrating factor dx plus c. So this one power will get cancelled. So we have integration of 1 by x square plus 1 dx plus c. This is nothing but tan inverse of x, right? Tan inverse of x plus c. So y into 1 plus x square is equal to tan inverse of x plus c is the required solution. But to find out c, they have given that to find c, they have given that so it is given that y is equal to 0 when x is equal to 1, y is 0, right? So that means this will be 0 is equal to tan inverse of 1 plus c. You just substitute x to be equal to 1, y to be equal to 0. So tan inverse of 1 is 45 degree. So pi by 4. So c will be minus pi by 4, right? So c is minus tan inverse of 1. The value of c is minus pi by 4. Therefore, the solution is y into 1 plus x square is equal to tan inverse of x minus pi by 4, right? The solution. We'll move on to 11th problem. One plus x square dy by dx plus y is equal to tan inverse of x, right? Tan inverse of x. So we will divide by 1 plus x square throughout. So that we will have dy by dx 1 by 1 plus x square into y is equal to tan inverse of x divided by 1 plus x square, right? So I'm dividing by 1 plus x square to make the coefficient of dy by dx to be equal to 1, which is a linear differential equation. P is given by 1 divided by 1 plus x square. Q is tan inverse of x by 1 tan inverse of x divided by 1 plus x square. The solution is given by y into integrating factor is equal to integration of q into integrating factor dx plus c, right? So we will find out integrating factor. So e power integration of p dx, e power integration of, what is p? It is 1 divided by 1 plus x square dx. It is nothing but what? E power tan inverse of x. So 1 becomes derivative of tan inverse of, sorry, integration of 1 by 1 plus x square is tan inverse of x, right? Okay. I have listed out all the formulas in the very first class itself. So go to the first class, right? Okay. Now what does 1 become? So y into integrating factor is equal to integration of, so what is q? This is p, right? This is p, this is q. So q is tan inverse of x divided by 1 plus x square into integrating factor is e power tan inverse of x dx plus c, right? Y into integrating factor is equal to integration of q into integrating factor dx plus c. So put t is equal to tan inverse of x. Therefore, dt will be 1 by 1 plus x square into dx, right? So tan inverse of x derivative is 1 by 1 plus x square. Okay. So therefore, we have this to be equal to integration. This will be, so therefore dt. Okay, let us keep this as. Okay. So we have this e power tan inverse of x is 1 by 1 plus x. Dx will be, okay. This implies dt into 1 plus x square is equal to dx, right? So I think it is visible. So dt into 1 plus x square is equal to dx, right? So dt is, and dx is dt into 1 plus x square. So t is tan inverse of x divided by 1 plus x square e power t, dx is dt into 1 plus x square. These two will get cancelled. So we have integration of t e power t dt. Again uv minus integral v du. So u into v minus integration of t du. So we will have, if we take e power t outside, we will have t minus 1. So replace t by tan inverse of x, e power tan inverse of x, tan inverse of x minus. So y into e power tan inverse of x is equal to e power tan inverse of x into tan inverse x minus 1 plus c is the required solution. If you are cancelling, you just have to write this as c divided by e power tan inverse of x, and then you can cancel it out, right? The required solution. So move on to 12th problem. So solve dy by dx plus 2y tan x is equal to sin x, given that given that y is equal to 0 when x is equal to pi by 3, right? Given x is equal to pi by 3. So we have dy by dx plus dy is equal to cube, right? Which is a linear differential equation. So therefore, the solution is given by y into integrating factor is equal to integration of q into integrating factor dx plus c. So let's call this as equation number 1. Now what is integrating factor? E power integration of p dx. So e power integration of p dx. So 2 times tan x dx. So e power integration of 2 tan x dx, right? So replace tan x by sin x by cos x. This will be log cos x, right? Will be e power integration of tan x sin x by cos x dx. But here cos x derivative is minus sin x. So minus is missing. Just multiply by minus minus. Will be e power minus 2. This log of cos x, right? So f of x, f dash of x. So take this minus 2 to the power. So e power log of cos x whole power minus 2. So e power f of x is f of x. So 1 by cos square x or 1 by cos x whole square. So 1 by cos square x is secant square x. So secant square x is your integrating factor. So substitute in one and integrate this part, you get the solution, right? So 1 becomes y into integrating factor is equal to integration of q into integrating factor dx plus c. This is a required solution. So y into secant square x is equal to integration of q is sin x, this secant square x dx plus c. Secant square x, I can write that as cos square x. So sin x into cos square x dx. Okay, it is very simple, right? Secant square x, and write this as let us write like this, right? Integration of sin x into 1 by cos x, 1 by cos x, right? I'm writing secant square x as 1 by cos square x, and 1 by cos square x, 1 by cos square x as 1 by cos x, 1 by cos x. This sin x by cos x is tan x. This is secant x, right? Dx plus c. So integration of secant x tan x is what? D by dx of secant x, right? That is, I can write tan x secant x as d by dx of secant x. Derivative of secant x is secant x tan x into dx plus c. So these two will get cancelled. So we will have secant x plus c. So therefore, y into secant square x is equal to secant x plus c is the required. Okay, we need to find solution. We need to find the value of c also, right? So it is given that uh, it is given that given y is 0 when x is 5 by 3. X is 5 by 3. So this will be 0 is equal to, right? So 0 is equal to secant pi by 3 plus c. So what is cos pi by 3? Cos pi by 3 is cos 60. So cos 60 is 1 by 2, right? So that this implies your secant pi by 3 will be 2. Because it is reciprocal, right? So that means c will be equal to minus 2. right? So therefore, the solution is given by required solution is y into secant square x is equal to secant x plus c. Right? Move on to next problem, 13th problem. Solve x into x minus 1 dy by dx minus x minus 2 into y is equal to x cube into 2x minus 1, right? X cube into 2x minus 2 this. So divide by x into x minus 1. Therefore, we have dy by dx plus minus x minus 2 divided by x into x minus 1 y, x cube into 2x minus 5, x into x minus 1, which is a linear differential equation, right? dy by dx plus dy is equal to q. P is minus of x minus 2 by x into x minus 1. Q is x cube into 2x minus 1 by x into x minus 1. The solution is y into integrating factor integration of q into integrating factor dx plus c. Now we will find integrating factor e power integration of p dx. So e power integration of p dx. So p is minus x minus 2 by x into x minus 1 dx, right? Let's call this as some star. Now we will find the integration of x minus 2 by x into x minus 1. Remember, this is what? It is a proper rational function, right? Because degree of numerator is strictly less than degree of denominator. So we can do partial fraction. Now, now consider x minus 2 divided by x into x minus 1. So it will be a by x plus b by x minus 1. So multiply throughout by x into x minus 1. So we will have a into x minus 1 plus bx, right? So I'm multiplying throughout by x into x minus 1. So put this is a very simple, right? So put x is equal to 0. So therefore we will have minus 2 is equal to minus a, right? This will be 0. So we have a to be equal to 2. Put x is equal to 1. So we have minus 1 is equal to b, right? This will be b into 1. This will be 0. So we have b to be equal to minus 1 and a to be equal to 2. So therefore, x into, so therefore, x minus 2 divided by x into x minus 1. Be a by x plus b by x minus 1. So a value is 2. 2 by x, b value is minus 1. So therefore, integrate on both sides, x into x minus 1 dx will be integration of 2 by x dx minus integration of x minus 1 dx. So 2 is constant. Integration of 1 by x is log x. This is log of x minus 1. This I can write log x square log x minus 1. So log a minus log b is log a by b. Right? So therefore, this is the integration value of this. So star, now substitute in star. Integrating factor is e power integration of minus x minus 2 by x into x minus 1 dx. So this value, right? This entire value is minus log of x square by x minus 1, right? That is, we have minus common. Integration of x minus 2 by x into x minus 1 dx is This I can write this as e power log of x square by x minus 1 whole power minus 1. So e power log f of x is f of x. So therefore, this will be x square by x minus 1 whole power minus 1. So x minus 1 by x square is your integrating factor, right? So integrating factor is x minus 1 by x square. So after finding integrating factor, now 1 becomes the solution is y into integrating factor is equal to integration of q into integrating factor dx plus c, right? So y into integrating factor is x minus 1 by x square integration of what is q? Q is x cube 2x minus 1 x cube 2x minus 1 divided by x into x minus 1, and the integrating factor is x minus 1 by x square dx plus c. So this x minus 1 will get cancelled. X square x cube will also will get cancelled. So we will have only integration of 2x minus 1 dx plus c. So 2 into integration of x dx is x squared by 2. Integration of dx is x. So we will have x squared minus x plus, right? So therefore the solution is given by solution is I into x minus 1. Right? If you want, you can also multiply this, take this term that side and so on, right? I into right. It's a very simple problem. So by looking at the question itself, don't judge that it is tough, right? So all are very easy one. We'll move on to 14th problem. So solve dy by dx is equal to x into x square minus 2y. Any doubt up to now? So we'll do two more problem and then we'll wind up. So 14th problem and 15th problem. 15th problem is solve dy by dx y cos x is equal. So we'll solve 14th problem now. Okay. So we have to just multiply x inside so that this will be dy by dx. So to multiply this, we will have minus 2xy. So bring that to this side. So 2x into y is equal to x cube, which is a linear differential equation. The solution is given by y into integrating factor is equal to integration of q into integrating factor dx plus c. Now we will find integrating factor e power integration of p dx, e power integration of, so what is p? It is 2x dx. So e power integration of square by 2. So e power x square, right? E power x square is the integrating factor. So 1 becomes y into integrating factor q. So q is x cube into integrating factor dx plus c. Right? Q into integrating factor plus c. So we have x cube. Yes, okay. cube have x cube into e power x square dx. Okay, so what we will do is put t is equal to x cube, right? What we can do is okay, so what we can do is let's write this to be equal to integration of square e power x square dx. Okay. To x dx plus, right? I'm just writing this x cube as x square into x. So put t is equal to x square. Therefore, your dt will be 2x dx, right? 2x dx. So 2 is missing, right? So what we'll do is we'll multiply and divide by 1 by 2. Multiply and divide by 1 by 2. Right? Now what we can do is this, I can write this as 1 by 2 integration of x square is t, e power t, and 2x dx is dt. Right? And this will be very simple, right? So uv minus vdu. So t e power t minus uv minus internal vdu. We will have t e power t minus 1 t plus c. So replace t is equal to 1 by 2. If we take e power t outside, we will have t minus 1 plus c. So replace t is equal to x square, the required solution. Into power x square. So we'll do one more problem and then we'll wind off. So 15th problem, solve dy by dx plus y cos x is equal to, this is a linear differential equation, right? Dy by dx plus py is equal to q, which is a linear differential equation. So the solution is given by y into integrating factor is equal to integration of q into integrating factor x plus c, right? Now we will find integrating factor e power integration of p dx. So e power integration of p dx. So it will be cos x dx, right? So p is cos x, q is sin 2x. Integration of cos x is sin x. So e power sin x is your integrating factor. So 1 becomes y into integrating factor is equal to integration of q. Q into integrating factor dx plus c, right? Okay. Again, I can write this sine 2 theta as 2 sine theta cos theta. This 2 sin x cos x or sin x dx plus c. Again, this is very simple, right? Already we have did put t is equal to sin x. Therefore, your dt will be cos x dx. So this will be integration of 2 into sin x is t, e power sin x is e power t, cos x dx. So cos x dx is dt plus c. So just take 2 outside. So integration of t e power t. So uv minus integration of v du plus c, right? So replace t is equal to sin x. So y into e power sin x. If I take e power t outside, have t minus 1 t. So replace t is equal to sin x, the required solution. The required solution. We'll stop here. In next class, we will continue with 16th problem, right? Actually, these are very important concepts. The next class, we will continue some more complex problems, right? Okay, is there any doubt? Next class we will start solving more complex problems, right? So that's it. So in this class, what we have did is we have started linear differential equation. So whenever you see an equation of the form dy by dx, dy by dx plus py is equal to q, where p and q are functions of x, it is called linear differential equation. How to solve? The solution is given by y into integrating factor is equal to integration of q into integrating factor dx plus c. Make use of this, find integrating factor, which is e power integration of p dx, and substitute back here. That is the required solution, right? So based on this, we have solved 15 problems. In the next class, we will continue with 16th problem, right? Thank you. You can download this PDF note in Telegram group. Telegram group name is Math Press. I will attach a link in the description, right? Thank you. All the best.